Okay, so this will be a video 4 in regard to our review of our final. So I'm going to go ahead and start on question number 22 on that for you. And on this one, we are to 22 just simply says, what is the ratio of sodium carbonate to water? So sodium carbonate is 1. Water is 10, so this is a ratio of 1 to 10. Okay, now what that's leading you into is when you get ready for this next step, this is the ratio that we're going to be looking for. Okay, now when you're doing a hydrate, which is what this would be, so this would be sodium carbonate decahydrate. So 10 is decahydrate. So what we're doing when we are calculating, we're going to be finding the mole ratio, and in this case 1 to 10. So here is our example. You have 15 grams of a hydrate of magnesium carbonate. It's heated without decomposing the carbonate to drive off the water. So in other words, this is like our blue stuff that we did. We took it back there and we drove off the water. We didn't actually decompose the copper sulfate that we had. We just drove the water off, assuming that we stopped at that spot. Then we masked what was left. So that's what's happening here. So this is what you start with. So this is the magnesium carbonate hydrate. So let's just write that down. Magnesium carbonate. Okay. Do be sure you check your subscripts and so forth for the magnesium and the carbonate. So magnesium is going to be a +2 and carbonate is a -2. So I do not need any subscripts. And what we're going to be looking for in this case, that's an X, is what is our water. So we're going to be looking for this ratio. Okay. Now for hydrates, guys, always the case, this number will always be a 1. That's what we're going to look for. Okay. So we're going to look for the X. Okay. X moles of water over 1 mole of magnesium carbonate when we get done. That's what we're looking for. Again, that's an X. So here's what it says. It said we started with this. The mass was reduced to this, which means that the difference in the two is the amount of water. Okay, so let's go over to the side and let's calculate the amount of water. Okay. And what is that going to be? 8. Okay. So this is our water. Okay. So again, you started with this. We reduced it down to this. So what we lost was our water. So this here is your magnesium carbonate. So we have 7.58 grams of the magnesium carbonate. And we have 8.09 grams of water. Now, for both of these, we're going to just do a gram to mole conversion. Okay, so we need to find the molar mass of magnesium carbonate and the molar mass of water. Okay, so I would pause that and let's find that value. Okay, so magnesium carbonate would be 84.31 grams. And water is 18.02 grams. Okay, so canceling everything. The rest is our calculation. So we need to take the 7.58 and divide it by our molar mass of 84, because again, this is in the numerator, this is in the denominator. So we're going to do a quick division. And we get this to be 0. And I'm going to go 3 digits. So 899. 0.899. And again, that's going to be moles of magnesium carbonate. Okay, moles of magnesium carbonate. I'm going to do the same thing down here. I'm going to 8.09 divided by 18.02, and that is going to give me 0.449 moles of water. Okay, now again, let's go back to what we talked about. We want this to be, again, just like this. So we want it to be slide this up a little bit. I want it to be a some number to 1. Okay, some number to 1. And in this case, it's always going to be the moles of water over the moles of your carbonate. There is what we're looking for. Okay, as far as an answer on a ratio, this to that or that to that, whichever you want to look at. But remember, this is very similar to an empirical formula. And so our empirical formula, in order to do that, or you could even just come up here to do this, two ways. Let me just go ahead and show you this one. Since we already have, and it didn't matter which way you wrote this, we could write this as, so like a ratio, and put this is my moles. Whoops, I got that backwards. Let me back up. Okay, so what we do is come up here and just put this again as moles of water over moles of magnesium carbonate. Okay, so just like a regular proportion, that's about 4. Okay, and so we're going to put the water, which is 0.449, and the carbonate is 0.0899. And so what you could actually do is work this like a proportion and cross multiply. Okay, so that would be one way to do it. Now, the other way that I showed you in class was to just divide by the smallest. So in this case, we would just come in here and again, divide by the smallest. And I'm running out of room, so sorry about that. Okay, and then when I divide, this is going to give me 1, and then this will give me, let's see what we get. I divide that by 0.0889, and it comes out to be 5.05, which is close enough to call it 5. Okay, which means that this value right here will be 5. So my answer to this problem, I'm going to go ahead and write it up here, would be magnesium carbonate times 5H2O. Okay. And again, you could have gone ahead and did a cross multiplication. I could finish that one out for you here. Now that I've done that below, we could just do a cross multiplication here. I'm going to just add some blank paper in under here and show you what I'm talking about. If you remember how to do a proportion, you cross multiply. So we get 0.0899x equals, cross multiply here, 0.449. And if you look at that, okay, there we get the exact same thing as I just had here. Okay, and all I'm wanting is what that x value is, because I told you the number in front of your magnesium carbonate is always going to be 1. So this is going to give you x equals 5, which would be the value out in the front. Okay, kind of two different ways to work it. Hopefully that makes sense to you on there. So you can either do it as a ratio or just come down here and we just shortcut it by just dividing by the smallest. Okay.